Hello, all. Welcome to week 8 of Learning Analytics Tools. Happy Ganesh Chaturthi to everyone. Shall we begin? Shall we begin today's session, or we should wait for some time? There are just five attendees. Yeah, of course. I mean, you all, there is link to the YouTube videos which I'll be posting. I mean, the recording that is already shared. Yeah. So, yeah, you're right. Okay, so we'll just quickly revise that we are now in the predictive analysis circle. Yeah, so we saw descriptive analysis, we saw diagnostic analysis, clustering mainly, and then predictive analysis. Yeah, clustering correlation we saw as part of diagnostic, and now in predictive, mainly we will be seeing the regression, different types of regression. Yeah, so I'll quickly give you overview of regression which was discussed, like simple regression, multiple regression, univariate regression, multiple regression, linear regression, and logistic regression and linear regression was mainly discussed in the lectures. So linear regressions for predicting continuous values and sorry. Mm-hmm. Oh, yeah. Independent. One is independent and one is dependent. Yeah. It should be. Yeah. So, yeah, typo. Like independent. Yeah. Single dependent and single independent. Thank you for pointing it out. Yeah. Hmm. Yeah, I copied from PPT. Did not see. Yeah, in Sir's PPT, this must be the mistake. So I copied it from there. Yeah. Yeah, so we use this simple linear regression wala formula where C would be intercept and Y would be slope. Yeah, and this will be dependent variable. Uh, yeah, dependent variable, and this would be independent. Yeah, so this is the for basic formula, which I think we have done in class 11-12, where we had given the data points and we had to point it on the graph and come up with the best fit line. So the same thing applies here. I think the similar thing we saw in the correlation also. Yeah. So linear and logistic. So logistic correlation will be used for categorical variable, the prediction of categorical variables, and linear will be used for prediction of continuous numerical values, continuous variables. So these are the important pointer as to which regression technique and where to use. Yeah. So that was it. I mean, yeah, and most of the things we have already covered during our clustering discussion. You know, how to minimize error and root mean square, or a minimum error, that R square value. So all those we have already discussed, like, you know, the difference between predicted value and the actual value. When we square that would give us the R square value. Yeah, I'll write it somewhere. R square value. So this discussion we had in detail when we were going through the clustering module. So that's why I have not included that in the slides, but we'll for sure discuss when the question comes up. Okay? So I'll just write it down over here. Predicted minus actual, the whole square. Whole square. Yeah? गिव मी अ सेकेंड। मैं पापा को कॉल करूँ, पापा का कॉल आ रहा है, मम्मी को अभी मेरे फ़ोन में था, वो खाने के लिए बुला रहे होंगे, तो उनको बोलो आते हैं हम। So that was a quickest recap of the this week's content. Yeah, so this we will quickly jump to the questions. Since it is festive time, we'll try to wrap it up as soon as possible, because we have already gone through the concepts in the different context, in clustering also, and in other things also. So all the concepts we will cover it, yeah, as and go. So we can start the MCQs. Yeah. So question 1, I will read it out loud, and then you can tell me what is the best answer you think is correct answer. Okay. So question 1, Prakash is teacher teaching the mathematics to the students of class 12 in a private school. He wants to predict students' end exam results in mathematics so that he can identify the weak performers and would be able to take measures to improve their performance. However, the data about students available is not sufficient for the teacher to predict their performance. Yeah. So now, based on this information, we have to choose that out of which options below we can, what data we can, additional data we can use to predict students' performance. Yeah. Yeah. So I will read out the options one by one. You have to say if that would be right, or that will not be giving us the regression model to predict marks in mathematics, okay, in class 12. So option A says performance results of the current students in other courses. Then option B says performance of results of other students in maths in previous years. Then C is performance results of other students in other courses in previous years. And D is attendance percentage of the current students in the current year and the attendance percentage of similar students in the previous years. So what do you think out of A, B, C, D? B and D you think is correct. Okay, so okay, B I will circle it, and D I will circle it. Okay, okay. Yeah, so I agree with both the options, like B and D would be correct answers. Definitely, I don't agree with C. C will not give us the insight about how the students will be performing in math subject in this year, based on other students in other courses in previous years. I mean, previous year's batch. How they performed in 12th standard, that will not be helping us in giving insight out how these current batch students, current 12th standard students will be performing in mathematics. But I think option A will also give us some insights that the current students performance in other courses. Yeah, so sometimes in Right, right. Yeah. So absolutely, option B is correct. I mean, yeah, I agree. How other students are performing in similar level of mathematics, because the syllabus of mathematics remains the same, class 12 ka syllabus. So all those things remain the same. So of course, option B is going to give us some insight. When we say this equation y is equal to mx plus c, so this is independent variable, but this is dependent variable. So this dependent variable could be historical performance, like what is the historical performance of other students for that particular course. That will give us, likely you said, that will give us where on which topic students generally have difficulty. That generalized idea will be, of course, will be given by this option, like in the past what was the performance of students. Yeah. And of course option D, like what is the current students attendance percentage in current year, and what was previously also what was the percentage. That will also help us in understanding how the current student will be performing in mathematics. That will help us in predicting their performance in this semester or this year. But additionally, I think we have to ponder on option A. Option C will not give us much insights, because they're the other students in other courses in previous years. So other subjects historical data will not be helping us out that much. Yeah, so I don't agree with option C. But in addition to option B and D, I think we should also analyze option A. Option A says performance result of current student in other courses. Yeah, so this is the point I'm trying to make. Like additionally to option B and C, of course B and C will help us in predicting their performance, and in addition to that, option A, which is their performance in other courses, like current student only, not the historical student. Like option C says ki past में last year or last to last year, in previous years, how the other students performed in other courses, that will not be helping us, but how this current student performed in other courses, that may help us. So I think correct answer should be A, B and D. Yeah, you agree? Are we on the same page? Yeah, yeah, so we can, yeah, so okay, thanks Srinanda. So we can move to question 2. So question 2 reads as, the predictive analytics in the education domain is helpful. Option A says, to the owners of institutions to predict the rank of their institutions among group of competing institutions. B, to the learning content developers to provide adaptive content to the learners. Option C says, to the instructors to adapt their teaching strategies based on students' performance. Option D says, to the learners to provide feedback and suggestions to avoid failures in the learning goal. Yeah. So anyone wants to attempt this question? A. Okay. B, C, D. Okay. 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 Anyone? Not part of learning analytics, but it's part of. Yes. Yes. Yeah. Yeah. So this is not part of learning analytics. From learning analytics point of view, it is B, C, D. Okay, so even though A could be used for predicting, I mean, yeah, A of course, but yes, of course, academic analytics. Yeah, so but that we can use predictive methods to predict the institute's rank also, but that's not part of learning analytics. From learning analytics point of view, predictive analytics concerns only this B, C, D 3 points. The content developer will be using to provide the adaptive content to the learners. See? Yeah, but for this subject, within the scope of the subject, that is not the right answer. Like option A is not right for this subject. I mean, for this NPTEL course, option A is not correct. Likewise, I mean, yeah, for prediction, it is even the bank fraud or predicting the stock market prices, and then customer behavior prediction. All these things is also predictive analytics. But yeah, that is not within the scope of this course. So likewise, option A is not within the scope of this course. Yeah. So there's no doubt regarding BCD, right? So yeah, we'll move on to question 3. So question 3 reads, regression is generally used. So we have to tell where all we can use regression. So A is to predict performance of learners, B to evaluate the strength of predictor model developed, C to investigate relationship between dependent and independent variable, and D to exclusively perform cause and effect analysis. So what? Yeah, A, B and C. Nice. A, B and C. Okay, so everyone agrees A, B and C. Yeah, we have had enough discussion on, or I don't remember, was it in the classroom or here, I don't remember. Have we discussed how correlation is not causation? Yeah, cause cause and effect is different and correlation analysis is different. Yeah, so anyways, the regression we cannot use to establish the cause and effect type of relationship. It will just give us the strength of relationship, which, like, y is equal to mx plus c. I'll again stick to the same simple equation where these are independent and dependent variable x and y, and this equation will give us insights about their relationship. Yes. Okay. So you remember in correlation also we have seen this, that we plot we do a scatter plot, and then we try to come up with a line where the root mean square error will be square error will be minimum. So yeah, the distance between, what is this, man, sorry, yeah, so the distance between this line and okay, so this line and these data points, yeah, this should be as less as possible, so that we can have this correlation will be stronger. Yeah, so now when we try to translate that same to linear regression model, so in linear regression model, this is the predicted line, predictor line, or the predictor model. Yeah, this line with some equation, say for example y is equal to mx plus c is the equation for this predicted model. So now this predictor model will have some predicted value for all the x coordinates, right? And whereas this will be the actual value of this point. Yeah, so this is the actual value and this will be the predicted value. Yeah, so when we want to evaluate strength of predictor value, we will use this r square as in difference between predicted and actual value. What is the predicted minus the actual ka square? Yes, equals to, yeah. So yeah, nobody's mic is on, so now is that echo gone? Now it's fine, right? Yeah, yeah. Okay, yeah. So so this difference between the actual value and the predicted value, say we have seen for this x1, we saw how the actual value what the actual value was and what the predicted value was. Similarly, if we do it like this, is the predicted value, like p2, and this is the actual value for this particular x point, so you can say a. So the difference between actual and predicted, if we square it, that will give us the r square value. So this yeah, so this strength, it should be closer to 1, like r square value should be closer, as close to 1 as possible, then it will be the perfect fit. So you remember the confusion matrix we have seen, I think in week 3 or week 4, I don't remember, we had seen that predicted value and this thing, the true prediction and false prediction. Yeah, yeah, so similarly for classification and for this thing also, are we predicting that value correctly? Like there will be a binary result to this model also, whether we have predicted correctly or not. So when we do it for logistic regression, that will be more clear, because logistic regression will have the categorical value. So similarly for this, we use this r square value. So this value, when it is close to 1, that means our predictor model is performing very well. Yeah, so we can use this for even to evaluate our predictor model also, how well they are performing. So since this regression is also a simple machine learning model, it is called glass box machine learning, because we can see what is behind this prediction. What mathematics goes behind predicting this value. So regression is one of the simplest machine learning techniques, which are also referred to as glass box machine learning technique, where you are giving some input and you're getting some output, but you know what maths is used or what formula is applied to get to the output value. So in that case, all the machine learning models, we can see the strength of the predictor model very easily. We can determine strength of the predictor model. So that's why even option B is correct answer. So even regression will give us what kind of, how closely these two values are related, and how these values will be, how one value will be used to predict another value. So that will give us some kind of relationship between them. So we can evaluate the strength of that relationship. And again, yeah, of course, we can investigate that relationship, whether there is a direct relationship, indirect relationship. This intercept value will give us some insights about the relationship. So all those things come. So apart from cause and effect analysis, regression model does everything. So yeah, moving on to next question. Choose the correct options which best describe the different types of regression analysis. So remember the slide which I showed in the beginning of this class? This is actually that slide only. So you have to tell me which options are correct. Question 4. I have to read all the options correct, right? Before. So multiple regression analysis had multiple dependent variable and multiple independent variable. Is it true? Multiple regression? No. Yeah. Second one is true. Multivariate has multiple dependent variable and multiple independent variable, so it is correct. Then multiple regression analysis has one dependent and multiple independent. Yeah, it is also true. And multivariate regression will have one dependent variable and multiple independent variable. Right? Okay, yeah. So B and C. So B and C are correct. We'll move on to next question. Yeah. So next question, there's a graph given and we can see three models, y1, y2 and y3. And now we have to see which regression model best suits the data. Yeah. So that means we have to come up with this R square, the actual data point. So can you see this blue? These are yeah, it looks like y1, but there is one data point over here also. Yeah, let me use some other color, maybe then it will be. Is this blue color visible? Yeah. Oh, sorry, yellow. I'm sorry, yellow visible? Yeah, it's bright. So these are the actual data points. Okay, so let me use blue only to have the predicted value. So this seems 20, 40, 60 and 80. Okay, so this is the x value, which this also seems to be 20 and I don't know what, 20, 40, 60 and 80. So this seems to be 0. For 0 there is this 50. One and 2 points, and we have to be like, so that's the beauty. Even though we can see 4 points are passing through y1, but this 1 point is so far away. For this 0, this is the intercept value, which we can roughly say 30, right? So 30 would be the value here, predicted value, and the actual value is 50. So the difference is, for all other data points difference is 0, but for this particular x is equal to 0, the difference is 20. So 20 square, right? 20 square, so that will be 400. It's not less. Yeah, so requesting Bijoy ji to please mute his mic, so that's causing echo, sir. Yeah, so I'm not realizing because I'm speaking, but for others, Bijoy ji, it's creating a little problem because my voice seems to be echoing because you're on unmute, so your speaker is also relaying my voice again to everyone. He seems to be away from his laptop. I don't know. Okay, ठीक है, we'll move on. Yeah, so for this thing, which one? y1. Okay, so this value we have gotten, sorry, not y2, y1. y1. Okay, so I'll choose the red color for y3. Okay, let's do for y3. So y3, this is the equation. 2 points are on the that linear model, which we have this thing. So 40, the value is 60, right? For 40, and this seems 50. On this it is 50. So this difference is 10. I'm writing it here, right? Difference is 10. Here this difference. Then difference here, this seems to be 70 and 50. So 20 square, this is falling here, this is falling here, this is 40 and 50, so 10. Yeah, so 100 plus 20 square 400 plus 100. This seems to be 600 for y3. Yeah, so now let's find out for y2. Yeah, let's do it for y2. Y2 seems to be blue. Let's use blue for y2. So this is y2. This seems to be, we can say roughly 5, or yeah, roughly 5, the difference between this data point and this. So let us have this as y2, 5 square. Coming here, this is seems to be lying on the line, so there's 0 plus 0 plus here this seems to be 50, and here, yeah, again it seems roughly around 5, something less than half, no, this, yeah, it is, seems to be 5 or 10, I'm not sure what it is. Let's take it as 5, we'll just underline it and we'll come back to it again. Now this seems here and here, so it seems around 15, this difference, yeah. And then, oh, I'm sorry, we considered wrong, no, correct, yeah, 15. This image is very distorted. What it should be, this is the difference is here, no? Yeah, more than 10 and less than 20, so roughly we can assume it's 15, like this difference, no? Yeah, so this we have considered, this is 0, this we considered 5, this we considered 15. No, this is not 50, this is less than 50. So let me erase this. No. Oh, okay. Oh, no, I'm considering this to be 20. So 20 ka 3/4. Yeah, you're right. Not 15, 8. Yeah. So, my bad. Sorry. This was 40, 60, 50. You're right. You guys are right. Let me remove this 15. So this would be 8. So is this 5 correct? 5 seems to be correct. Yeah, 5 seems to be correct. Okay. Because I had zoomed in, so somehow that distance seemed like 20 wala thing. Yeah, you guys are right. It seems to be 8. Yeah, yahan pe. This difference. Yeah, you're right. Yeah, so this point, and now we are here. This is 10. Yeah, 40 and 50. 10 square. Yeah, so 25 plus 25 plus 64 and 100. So 50 plus 164. So this seems to be the answer for R square. So which is the minimum value out of 400, 600 and 214? So what would be the correct answer? Y2. Yeah, so yeah, B option seems to be the right answer. Yeah, so even though instinctively it was like, okay, y1 seems to be having most number of points on the model, right? So all of us, yeah, even I thought when I first looked at it, I thought, okay, so clear cut y1 hai, because just one point which is not on the line. But then we have to be very careful, because the R square value said the otherwise, no? R square value said that y2 seems to be the best fit, because wo difference between the predicted value and the actual value seems to be minimum for y2 model, and not y1 and y3. Yeah, even though y1 and y3 both the models had some points on them, whereas y2 may, I think just one point was lying on the model line. Yeah, so if you get this kind of question in your final exam also, don't jump to the conclusion by just looking at the graph. Okay, carefully evaluate which would be the best fit model. Yeah. So now moving on to next question. Next question is again a little bit easy. Yeah, same formula we have been given this formula, you know, y is equal to 36 plus 0.6x. So if you recall the formula, So Bijoy ji, I'm again requesting you to please keep your mic on mute if possible. Yeah, it's no, I can't. I'm not able to mute, it seems. Yeah, I'm not able to mute. I tried some time back. Yeah, but now I think he has muted it. Yeah, so now I think echo is gone now. Yeah, so this formula, if you recall, like y is equal to mx plus c. So m gives us slope and c gives us intercept. Yeah, so by after looking at the formula, we can tell what would be the value of slope, what would be the value of intercept, right? Yeah, so what would be the intercept value? 36. And what would be the slope value? 46. Yeah. So now this is the table which is given to us, student ID, and mid-sem marks are given and end-sem marks. So what they have asked is, there's a linear regression model between mid-sem marks and end-sem marks using this training data set from ID 1 to 5. So this 1 to 5 seems to be the training data set, and we have to find a value for this. So that means this is x and this is y. Why? Because we have to find the end sem, we have to predict the end semester marks. So can you quickly put these value into this formula and tell me what is the predicted value for this? Do I need to open my calculator to do this? Okay. 54. Okay. I need to 0.6 multiplied by the mid semester marks, 30. So 18 plus what is this thing? 36. So 54. Okay, great. And 60. Let's try doing that. What is this marks? 40. 24 plus 36. Yes, 60. You're right. Third one is, what is it? 66, huh? Okay. Fourth one. No, this is 20, no? It will be, yeah, it's 48. Everyone's getting 48. Yeah? Okay, and last one, 0.6 multiplied by, no, 42. Yeah, you're right. 42. And what is this last one value? 0.6 multiplied by 80. 0.6. 48 plus 36. Yeah, 84. 84. 84. Yeah. So we have this column of actual values, right? These are the actual values, and these are our predicted values. So let us have their difference point out noted down here. So difference is 4, difference here is 0, difference here is again 4. So we will be squaring it, so the sign doesn't matter here. Okay, so mean square wala aa hi jayega, so we don't care if it is positive or negative, the difference is positive or negative. Okay, so the difference here is 8, difference here is again 8, and here we will not, since we are predicting, so our training data set is from 1 to 5, so here we are not concerned. Okay, so let me write down square of this difference over here. 0, 16, 8 square 64, and 8 square 64. Yeah. So what will be the final r square value for this? Yeah. So 16 plus 16, 32 plus 64 plus 64, 160. Yeah, 160. We'll just add all the values, right? 160. Okay. Yeah, so we have calculated everything, like r square value, predicted value for everything, and we have also seen the what comes for this testing data set na, for value 80. What is 80 person scoring 80 in mid-sem mark? What will be the predicted value using this particular model? Which model? This model. Yeah. So now let's look at the questions. What is the value of intercept? So easy. Yeah. No, we did not get. This is the difference between predicted minus actual value. This is the difference. Which is r, and this is r square, because the error minimizing function works as root means square value. No, there we don't have the actual data, no, last row mein. We don't have actual data. This is our testing data set. We don't have the actual value here, na. We have to predict. For a student scoring 80 in mid-sem, what will be the score in the end-sem? That we have to predict using this formula. Yeah, so that's why we are not considering the difference here. There is no difference. I mean, from where you will subtract this 84 value. We don't have the actual data. We are just predicting for a student scoring 80 marks in mid-sem, his end-sem performance might be around 84. Yeah, so how to evaluate whether our this thing model is working, what is the strength of the model? For that we have to calculate the r square. So r square may we always consider difference between the actual value and the predicted value and square that difference. And since our this size is 5, the testing data set size is 5, we will add these square values to get the r square for the model. For the model as in our 5 these whatever this equation for the all the 5 data set values. So what I have done is I have added these value to get the r square value for this particular model. Yeah, very simple. The same thing we did in clustering, no, correlation, not clustering. Correlation maybe we did that. You remember in correlation also the difference between the actual data point and the model. So that model or the line was this model here in the clustering also. Going by the 5 available 5. Yeah, okay. So now going to the questions. Question is, what is the value of intercept? This is the equation. What is the value of intercept? Option C. Yeah, 36. What is the value of slope? I want to see 0.6. Very simple, very easy. Now what is the least square error calculated from for ID 1 to 5? We have already seen why we consider 1 to 5 and not consider 6. So what was our answer? Oh god, our answer is 160, which is not part of this options at all. Okay, by intuition I'm going to say this seems to be the nearest, so this should be the answer, right? Okay, I'm amused how our answer is not the part. Let's cross check again whether I have not made any mistake. Yeah, 50, 54 difference 4, 4 square 16, 0, 66 and 70 difference is 4, square 16, 40, 48, 8, 50, 42, 8, 64, 64, 10, 10, 22, yeah, 16, 18 and 19. 16. Yeah, my r square value seems to be 160. Am I making some calculation mistake here? No, right? Okay, this is nice. Okay, so by intuition I'm gonna say B seems to be the answer. Okay, because our value is 160, so the closest here is this 153. Yeah, no other value seems to be even closer to 160. Okay. I'm not sure how to handle this. Yeah, my calculations seem correct. The answer is not part of the options. Okay. Yeah. Let's see. ठीक है. So question 9 says, from the given linear regression model, predict the end-sem exam for student 6. We already have this predicted value. We had written it here. So 84. Yeah. So is this 84 in the answer? Yes, it is. Option C seems to be the right answer. Okay. So thankfully this is correct. So here I think some mistake from last question paper or the portal. I got it from the portal, so some mistake from there. Okay, so we'll move on to question 10. Which of the following is true for logistic regression? Okay, logistic regression, not linear. Okay, you have to be very careful. We have to give answers for logistic regression. So option A says logistic regression is suitable to predict categorical value. That's correct. Yeah. Since it is R, there could be multiple answers, right? So I'm going to continue reading. C says logistic regression is suitable to predict continuous value. No, for continuous value, which type of regression we? Linear, right? Yeah. Somebody has very very loud background noise. I'll please request everyone to mute. Yeah, thank you. Yeah, option C says logistic regression uses maximum likelihood as error minimizing method, and logistic regression uses least mean squared error as the error minimizing. So again, least mean square is used in which regression model? Linear and not logistic. Yeah. So A and C are correct answer. Okay, so we are done. Yeah, so all the 10 questions are done. This week, I mean, we have already done the fundamentals, so same things got repeated, and many things were easier. So if there are any doubts, we can discuss now, or otherwise, yeah, we are done with the questions. Probably the fastest, yeah. First, this question, we discussed it like really long time. Okay, so they are telling us that they don't have sufficient data to come up with the proper model to predict marks in mathematics, so that teacher can have remedial classes accordingly. They can predict the performance in the final examination, and then have remedial classes to help out the students who are predicted to have lower performance. So that's the whole point of having predictive analysis, so that we can catch the students who may not be able to achieve the learning outcomes properly, so that we can help them. So how we can help them is either by providing them tailored content or adaptive content, either in the classroom or in the online or computer based teaching learning setting, or for teachers to modify their teaching strategies in the classroom, or help them with the remedial content, help them understand the content better, help them perform better. So that is the aim. It's a multiple answer questions. No, there are multiple answers. So we discussed how A, B and C are correct answers in the beginning only. So I'll repeat the same thing. So when we don't have enough data, sufficient data about the current student, so how they are performing in the other subject, the same set of students, when we say current students, so how they are performing in other subject will give us some information that can be our independent variable on which the performance of maths, if we consider that to be dependent variable, then we can have some relationship between performance in other subjects and performance in maths. So A also makes sense, that if we have their performance in other subjects, we can have some model, some linear regression model for them in order to predict their performance. Option B says performance of other students in mathematics in previous years. So in previous years, because the syllabus remains the same, so this a very very good point was raised in the class. They said that their performance will give us insights about which topics are usually found difficult by students. More generalized pain points will be pointed out by this option. In last year or last to last year, and some last 2 years, last 3 years data will show us on which topic students have difficulty in scoring. So we can use that also to conduct remedial classes focusing on that particular topics. That's why option B is also correct. And we will come to option C at the last. Option D says attendance percentage of current students in current year and attendance percentage of similar students in previous years. So when we compare the historical data, I'm calling that at historical data, the previous years. So if we compare historical data with current year data, that comparison will also give us some insights about how the student may perform in this current year. Yeah, so that's why option D is also logical. I mean, yeah, it has potential to help us with the model, coming up with the model, regression model. Now coming to option C, performance result of other students in other courses in previous years, in last 1 year, last 2 years, last 3 years, how those students were performing in different subjects, not maths, in subject other than maths. That will not give us that will not help us in coming up with the regression model, right? How they are performing in science, or how they are performing in physics, chemistry, maths, or English literature. So that will not be directly helping us with their predicting their performance in this year in math subject particularly. So that's why only C option does not seem to be giving us that we can't be using that successfully to predict students performance. But rest other variables, we can use them in predicting students performance. Okay. Yeah. Just a minute, this seems to be hung. Why? Okay, I don't, wait. Wait. No. I don't know what has happened. Wait a minute, I'm trying to navigate. Yeah, so this thing, we have calculated the difference between actual value and predicted value. We are minimizing the error function here. We are trying to calculate the objective function or error function here. So this says that R value, gosh, I'm sorry. Yeah, so R square is difference between the actual values minus predicted values, the whole square. This is what we have done for all the values. Okay, so in yellow line we have calculated the difference between y1, actual values of y1, and the difference between the actual value and the predicted value. So out of 1 2 3 4 and this fifth value over here on the y-axis, so out of these values we have seen that only one value seems to be out of this line, the model line, and the difference between the predicted value and the actual value for that seems to be 20, and 20 square is 400. So R square value for y1 is 400. Similarly for y3, this is with red line, these are the y3 calculations. These are the actual predicted value. On the, for all points, predicted value seems to be 50. So we will calculate difference between 50 and the actual value of the data point, like 60 minus 50, 10. So 10 square. This difference is 20, like this is 70 minus 50, 20 square. Now coming, this is falling on the line and this is falling on the line, so only one point, which is one data point which is not on the line, is this. The difference between 40 and 50 is 10, so 10 square. So we come up with the 600. R square value is 600. Similarly for y2, which is the purple line in the graph here, we have calculated difference for every data point. Yeah, so we started from top and we came to this last value over here. So this difference seems to be 5 square. Then this one point seems to be lying on the line, so 0. Then again this is the data point, this is the predicted line, so this difference we saw is 5. Then coming to this point, this difference seemed to be 10. Between the predicted value, this is the actual value, predicted value, and this is the actual value. So we saw this difference seems to be 8. And then lastly, the last data point, like 50 minus 40, so 10. 50 minus 40, 10 square. So this difference came out to be 214. So the least value for R square, the least value is 214, which is y2. So that's why answer was B, y2 only. Yes. No, 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 no. Don't get confused. We are not minusing any value with the any other model. What we are doing is predicted value minus the actual value. Yeah, so actual data points were marked in the yellow. These yellow points you can see, these are the actual data point. One was here at the 50. Yeah, so 1, 2, 3, 4 and 5, there are total 5 data points. What we did was we saw what is the corresponding x value for all these data points, and then what seems to be predicted value. This is predicted value, this is x value, this is actual value, and यहाँ पे this is y2. So this is predicted value over here. So this is what we did. We saw x intercept, we saw y intercept of this particular point, and then the y intercept is predicted value for this value of x, right? So the difference between this dot and this dot, this dot and this dot, then again this value and this value, this value and the predicted value, y2 ka prediction is over here for this 20, no, whereas the actual value says 40, but prediction for y2 is 50 or less than 50, some 48 or something. Yeah, so this difference was 8. Likewise, we calculated what is the actual value and what is the predicted value for that particular y point. So we saw, yeah, too many marks on the graph, that may create some confusion. So I'll just try to erase all the marks, and then I will ask you only what seems to be different. Yeah, so now can you see the dark points, the blue points which are there on the graph? Those are the actual points. Yeah, I will again use the yellow color to highlight so that it looks bright. Yeah, 1, 2, 3, 4, and this here it is 5. Yeah, so 5 values. So now for better understanding, let's start with y1. All these 4 values seem to be on y1 using black ink, because this is y1 black. Okay, so now for this 0 value, the predicted value over here is, yeah, somewhere between 20 to 30, which is 30, half between 20 and 40. Yeah, so this is the predicted value for x is equal to 0. Mid-sem marks 0, so end-sem should be 30. That is what our predictor model says. But that student's actual value, actual data point is over here at 50. So what is the difference between actual and predicted? 20. So what will be the r square value? So here it is, for y1 it is 400. Okay, r square value for y1 came to as 400. Okay, so now let us go for y3, because y3, what y3 says, for all the value of x, y value is 50, right? For all the values of x. Yeah, so what we have to see is, for all these values of y, there will be different points with different difference. Okay, so now let's start with this 50 point. What will be the difference between actual and predicted for 50? Y is equal to 50. 0. Yeah, so 0. It is lying on the model. Yeah, it is lying on the model. That is this is our prediction model. I will change the color to red. Yeah, y is equal to 50. Yeah, so this is lying on the model, so difference is 0. Now next data point is over here. What is the difference between this 50 and this? This is 40 and this is 50. What is the difference between actual value and the predicted value? Actual value says 40, predicted value is 50. What is the difference? 10. So here we have written 10. 10 square 100. Now moving on to this point. What is the difference between actual and predicted? Shreya, I am waiting for you to answer. I'm asking, I'm asking what is the difference between the predicted value and the actual value for this particular data point. This for with respect to y3. No, y20. This is the data point actual. Yeah, and this is our line predicted. Predicted model also says y is equal to 50. And what is this actual data point? What is the y value for this? 50. So 50 minus 50 is 0. Yeah, it was so simple, 0. So now moving on to this particular point. Now you tell me what is the difference between actual and predicted. 10 square 100. Yeah, so 10 square 100. Now this point which comes over here. Yeah, 70 minus 20 square 400. So we have written here. So what becomes the r square value for y3? 100 plus 400. Squaring, yeah, squaring and adding. So 600. Now coming to this y2 purple line. Let me change my ink to blue. Okay, y2. So now this is y2 and this is actual data point. So what seems to be difference here? Let us try to map this. Yeah, so this is 10 and this seems to be 5. Do you agree there is difference of 5 between actual and predicted? Yeah, so 5 square. I have written 5 and bracket square. Now this point coming to this point, second point, is it lying on the model? Purple line? Yes. So what will be the difference between the predicted value and actual value if the point is lying on the line? y25. How the difference is 5? Yeah, how the difference is 5? Tell me. I think you are okay, Shreya, stop. Okay, so I think you are getting confused. Okay, this yellow with the blue dot, like this thing which I am highlighting, is the data point. Now let me erase everything else. Now again I will mark this as data point which is lying on y2, this purple line. Do you agree it is lying on y2? Yes. So for all the points which are lying on that particular model line, the predicted value is also same. Model y2 says for this particular value of x, which is what? 40. For this 40x, that means 40x matlab 40 mid-sem marks. The end-sem marks will be 60. Do you agree? Yeah. So now we have to consider only the end-sem marks, difference between the actual end-sem marks and what our model is predicting. So model y2 is predicting for x is equal to 40. The end-sem marks are 60. And what is the actual data this point is saying? 60. So what will be the difference between 60 and 60? 60 and 60, 0. Shreya, don't get confused. This is the point. We have to find difference between the given data point and the data point which line is suggesting. Y2 line is suggesting value 60 and the actual data point value is also 60. So the difference will be 0. Yeah, so we will be writing this 0 over here. Now coming down to this particular point. Now let me erase again this red marking. Yeah. So now if we come to this point, what is the actual value at this point? What is the actual value? 50. It is not 60. 50. And what our line is saying? Line model is saying okay, yeah, So line model is saying for this value of x, roughly 55, approximate we can say, Shreya, this value is 55. So what will be the difference between actual value and predicted value? 5. So we have written 5 over here, right? This 5 square. So now coming to this last point, which is below this, yeah, this point. Now you tell me what is the actual value? Roughly 40, yeah. And what will be the predicted value? No, we are on y2, this purple line, yeah. This somewhere here on this blue point, yeah. We have to see where it is intercepting. What is the y-intercept for that particular point? That will be our output, right? We can say roughly 48. Yeah, we can approximate 48. Okay, that's what we had decided. We'll consider it as 48. So what will be the difference between actual value and predicted value? 8. So we have written 8. Yeah. So last data point is this yellow line over here. Let me make it blue. This, and inside yellow, yeah, this is our last data point, and this is our intercept. Here purple line is intersecting at 40 and this is 50. So what will be the difference? 10. So we have written over here 10 square. So we will square everything and we will add. That is coming to 214. So what our theory says is that mean squared error value should be minimum. Yeah, the squared error should be minimum. So for which model squared error value seems to be minimum? 240. So which seems to be best fit or best suited for our data? Option B, y2 only. Yeah. So there's only one simple formula, Ashwini ji, actual value minus predicted value, and you have to consider square of it. That will give you squared formula, error square. And that error square value should be minimum. Yeah, that's what theory said. Very simple. Yes, squared error, yeah, squared error. Yeah, so don't get confused, Shreya. Remember this simple formula. What is the actual value and what is the predicted value? So you have to look at the graph very carefully to understand which is the actual value and which is the predicted value. Get the difference, square it and add it for individual model. So things got confusing because there are 3 different models here. Yeah, so now are you clear? Are you confident that if similar question comes, you will be able to solve? Yeah. Practice a bit more. Yeah. Yeah. Okay. This one intercept, this is based on this value. Y is equal to 36 plus 0.6 into x. That's the formula given to us from here. And based on this formula, we have to see what is the intercept. So if you see the formula, y is equal to mx plus c. So c is the intercept. This is the equation of the line, simple, because we assume in linear regression the relationship is linear. So that's why we are using simple line equation. So m is slope and y is intercept. So can you compare these two equations and tell me what will be the value of m and what will be the value of c? So can you tell me what will be the intercept? So out of options, what is the intercept value? A, B, C, which is option C, right? And similarly, what is the slope value? 0.6. You just have to compare this line equation with the given equation and deduce what is the value of m, what is the value of c. Okay, okay. Hmm. It's the same. By putting the value of x in the equation, this is the x. Mid-sem marks are the x value, x variable for us, because we are using mid-semester marks to predict the end semester marks. Yeah, so this is the x value and end semester marks are the y value. So we are putting all these values as x in this particular formula over here at the bottom, and that's how we got all these values lines here 54, 56 for this particular value. If you put x is equal to 30 in this formula, you will get y as 54. So you have actual data point, actual value 50, predicted value 54, difference as 4, squaring that gets 16. If you put x value as 40 in this equation, you will get y value as 60. Actual value is also 60. Put it in the equation, yeah. X in the equation. Yeah. And then you have to find the difference between these are the actual data and this is the predicted values. So difference between actual value and the predicted value is I have noted in this column and then squared it here, and then adding that square has come up with the r square value, which is squared error. Yes. That is not 16, that is r square value. This y is like endsem marks I have written. Endsem marks is our y variable. Here I have written in the red this thing. Let me correct it. It is not. This is actual or y and this is the r square. This is the difference. And this is the r square. Yeah, so if there are no more errors, then we can probably end today's class. Yeah, this was fairly easy content, so I was expecting today's class to end faster and sooner than usual, because we already know the concepts. We have seen the concepts before in correlation and clustering, so we have some basic understanding about how to read the graph. So this was expected. I mean, I was expecting today's session to get over faster, sooner. Yeah, so again, happy festivities to all. Yeah. Okay, ending the meeting for everyone. Okay. Yes, happy Ganesh Chaturthi to you all. Yes. Yes, yes. Happy festivities. Yes, you all. See you next week. Yeah, bye. Good night.